This is the AEC 204 Materials and Methods exercise. Um, you're originally supposed to take the quiz in class or at a later date, and then you had the hands-on portion of NCCER. Uh, Based on this semester how it's going, there's no way you're going to be able to finish your NCCER training. So what we've done is, for the classes that you did not finish relating to NCCER, we've come up with different exercises. This exercise is for AEC 204 Materials and Methods. And what we're dealing here with is concrete. So what you're going to be doing is basically pretend like you actually went out and you mixed concrete, and then you filled up your vessel and you weighed it, and then you started getting your unit weight, yield, and air content. So I want to explain this to you. You'll print it out, put your name on it, and then you'll do all the problems here, and then you'll scan it in or take a picture and send it back. So, kind of explanation, we've already weighed your vessel for you. When it was empty, this is what it weighed. The volume is listed there. So now, once it does get weighed with the concrete in there, it weighed 7,818 grams. We converted that to pounds, and then so you will actually solve the mass. So there's the formula to solve for mass. That gives you your mass. So you're solving for M. Then you'll move on to unit weight, or what is known as density. So if you look at everything, we've identified everything that you need by the letter of what you're trying to solve for. In this case, you're going to be getting density, so it's mass divided by volume. And so D, which is density, equals mass divided volume. You already solved for M, which is your mass, so that gives you your density. You know, volume is this number, and cubed. So okay. Then next you're going to do air content. So T, which is solving for theoretical density. There's your number for T. So your air content will be in percentages, so it's basically theoretical density minus unit weight divided by theoretical density times 100. What we've done is broke down this to two individual mathematical problems. So you're going to solve for C right now, which is theoretical density minus theoretical density minus density. All right. So that gives you Z. Then you're going to do Z divided by theoretical density times 100, and that'll give you your air content. All right. So now we're going to do yield. All right. So we know that the design batch volume is 0.6 cubic feet, and so design batch mass we know that is 80 pounds. All right. So what we're going to do is here, this already gave you the design batch density. All right. So what we're going to do is get the actual volume produced. So what we're going to do is actual volume produced, AV. So we're going to use density from above, this one here. So we're going to say AV equals design batch mass, which is this one, divided by density, which is this result you got here. That gives you that solution. All right. Relative yield, we're going to take your actual volume, which is AV here, divided by design batch volume, this number here, and that will give you your relative yield. So the formulas kind of give you an idea. You just kind of have to, focus them back to what those initials stand for. So hopefully this makes sense. What you'll do, again, you'll put your name, do out all the formulas, mathematics, and your solutions, and then scan it or take a picture of it and send it back to us. Thank you.